Students, this is me, your lecturer, Mrs. Mogiade, and I'm here to briefly talk to us on simple analytical techniques. Simple analytical techniques in chemical pathology. So it's also an introductory kind of class. So when we say simple, what do we mean? Simple analytical techniques in chemical pathology, they include, these are techniques that are not really sophisticated. They are routinely used techniques in chemical pathology that are used to carry out analysis. So we have spectrophotometry, for example. We have colorimetry. We have chromatography. We have titration. We have microscopy. Okay. Now, these methods are used to identify, quantify, and characterize various substances in biological samples. So, you look at the spectrophotometry and colorimetry. So that this technique measures the absorbance or transmittance of light through a sample. So, when you have a sample preparation in the lab, you know, at the end of the day, you put it, after preparing the sample, incubating for the amount of time that one is required to. It is being put in the spectrophotometer on the colorimeter. Wavelength is being selected and the current is being put on. And when light passes through that cuvette, it gives out colors. So at the end of the day, colors are being given out. The monochromator selects light of specific wavelength, and at the end of the day, absorbance reading is being taken. Yes, it's being taken and calculation will be done and the result will be gotten. Then look at chromatography. This method separates different substances in a mixture based on their physical and chemical properties, allowing for the identification and quantification of individual components. So you have immiscible liquids, two immiscible liquids, and at the end of the day, the substance will pass through it and separation will take place. So many factors can affect the solubility rates of the substance being added can affect. There are so many factors. Even the rate of flow, of the substance can also affect it. So that is for chromatography. It's a method for separation of substances in a mixture based on their physical and their chemical properties. Then we see titration. This technique involves adding a solution of known concentration. That solution of known concentration, which is the titrant, is added to a solution of unknown concentration until a chemical reaction is complete, allowing for the determination of the unknown concentration. So, and also an indicator is added to that solution. So at the end of the reaction, when the reaction is completed, an endpoint is being gotten. Yes, endpoint which will be gotten as a result of color change or precipitation. So titration is when a solution of known concentration is being what? Is being added to another solution of unknown concentration. At the end of everything, the concentration of the unknown will be determined from the reaction when it is complete. The another equipment to have is microscopy. This technique uses magnification to observe the fine details of biological samples, aiding in the identification and characterization of cells, tissues, and microorganisms. And these techniques are widely used in chemical pathology for various purposes, which includes 1. For assessing blood and urine chemistry. Under this, analyzing the concentration of electrolytes, proteins, enzymes, and other substances in bodily fluids. 2. For drug monitoring, determining the concentration of drugs in the body. 3. For biochemical analysis, studying the metabolism and function of biomolecules. 4. For pathology diagnostics, identifying and characterizing various diseases. So we also have the flame test. These tests involve heating samples heating samples in a flame, and observing the color of the flame to identify the presence of certain metallic ions. So the test we do in chemical pathology is basically under two headings. We have the qualitative test and the quantitative. For the qualitative, it looks at the quality of what you are analyzing. Yes, it looks at the quality. It looks at, for example, the color. Did the color change from blue to red? Okay, if that particular analyte is present in the reaction, okay, is it present in 1 plus? Is it present in 2 pluses? What is the amount? The amount now we're looking at, not the right quantity now. That's why I use the word quality. Is it present or not? So things like that is positive or negative. But we also have the second one, which is the quantitative test, that looks at the true value. What value of it is present? If, for example, we're analyzing glucose, what is the value of glucose? Is it 100 milligram per dl? Is it 200 milligram per dl? So it gives you the amount, the quantity. So that's why I said our test in chemical pathology is grouped under qualitative and quantitative tests. So some other analytical techniques in chemical pathology. We have immunoassays. These tests use antibodies to detect and quantify specific molecules like hormones, proteins, or enzymes in a sample. We also have electrophoresis. Yes, this method separates molecules based on their charge and size, allowing for the identification and quantification of proteins or other charged molecules. So it looks at their charges, positive, negative charge, etc., etc. So we also have some other equipments that are being used. Some other analytical techniques that are being used in chemical pathology. Okay, so also in chemical pathology, for our techniques, we also have what we call wet chemistry and dry chemistry. Now, wet chemistry is also known as wet chemical analysis or bench chemistry, which refers to analytical chemistry techniques that involve liquid-based methods. It encompasses a wide range of techniques used to analyze elements and compounds in liquid samples, including colorimetry, gravimetry, and titration. Yes, that is wet chemistry. So we also have key aspects of wet chemistry. We have the liquid-based methods. Wet chemistry primarily involves chemical reactions and analysis conducted in liquid solutions. It can provide both qualitative information and quantitative data. The wet chemistry often utilizes established techniques like titration, colorimetry, gravimetry, and distillation. So examples of wet chemistry techniques, we have the colorimetry, like I've been saying since, gravimetry, titration, spectrophotometry, pH measurements, distillation. So what are its advantages? Advantages is that it is cost effective. Wet chemistry methods are generally less expensive than some instrumental methods. Relatively simple, they often involve straightforward procedures, they are widely applicable, they can be used for a broad range of analysis. So while wet chemistry is a valuable tool, it's important to know that it can be time consuming and it requires a high degree of precision. So we'll briefly look at the dry chemistry. Dry chemistry, also known as the solid phase chemistry, is an analytical technique where reagents are in a dry form, typically as a strip or impregnated matrix. A liquid sample is added to the dry reagent and the moisture in the sample serves as a solvent to dissolve the reagents and initial chemical reactions. This method is used for various tests, including urine, blood, and plasma analysis. What are the characteristics of dry chemistry? Reagent format. The reagent is in a dry state. Liquid sample as solvent. The solid phase chemistry. The dry reagent is in a solid form, allowing for easy handling and storage. Enzymatic methods. Many dry chemistry analysis are based on enzymatic reaction. What are the advantages of dry chemistry? Simplicity and ease of use. Very simple. Dry chemistry analyzers are often user-friendly, requiring minimal training. Reduce waste. Reagents are utilized and used individually, minimizing waste. Portability and convenience. Some dry chemistry analyzers are portable, making them suitable for various settings. Also, cost effectiveness. Dry chemistry can be more economical than the wet chemistry. What are the examples of dry chemistry applications? Urinalysis. We are going to talk about it. Testing for protein, glucose, ketones, and other analytes. Then for blood chemistry, measuring blood glucose, cholesterol, triglycerides, and other parameters. Then there are also other applications. Dry chemistry techniques can also be used for specific medical tests in diverse settings like hospitals, clinics, and emergency room. Yes, like the point of care test is a dry chemistry. Even our automation, they are also dry chemistry. Okay, see you in my next class. Bye.